So my name is Matt Stedl with Tradewind Energy, and as Adam mentioned, I lead the energy storage development at Tradewind, and really happy to be here today about this really exciting topic. Just real quickly about Tradewind Energy for those in the room that don't know us, we're a large wind, solar, and energy storage developer headquartered in Lenexa, Kansas. We've got projects all over the Midwest and various parts of the United States. We actually were the #1 wind developer in the U.S. last year, been growing quickly and really proud of our efforts in all the markets that we are in. Here's a representative list of some of our customers, both utilities, commercial, industrial customers, and hopefully there are some existing and new customers in the room today. So glad to be here. As far as the topics that I'm going to discuss, Adam mentioned, there's a variety of different configurations and applications for storage. I'm going to focus on front-of-the-meter applications for storage. So largely this is utility scale transmission connected projects, though this could apply to co-op or muni type applications and potentially some smaller projects that have front-of-the-meter or wholesale market participation availability. But in general, this presentation is going to be about wholesale utility scale transmission connected projects. So talk about applications, some configurations, dive a little bit deeper into wind plus storage, and then discuss some of the challenges. So in terms of what storage can do in front of the meter, I like to kind of take a step back, and this is like a real high level description of what storage does. So the first is energy time shift. So we charge it at a certain time and we discharge it at another time. This is sort of intuitive to storage. And is one of its main use cases. Another use case is firm capacity. So as Adam mentioned, wind and solar, intermittent generators, and wind in particular is very difficult to predict on a long-term basis. Though short-term, we're pretty good at it. So storage can provide firm capacity, shock absorber. So this is most represented by frequency regulation. So one of the market products that SPP has and all of the ISOs have is a regulation product. So basically this is fast charging and discharging of the battery in order to stabilize the frequency of the system. And this is going to become more important as more intermittent resources become part of our resource mix. And storage is really good at this and really fast. So that's an application that is being used in a lot of ISOs right now. T&D deferral or transmission and distribution deferral. There's a lot of use cases for this, putting in storage in lieu of transmission or distribution. And then the last one there, backup power. Question mark there, it's just in terms of whether a front-of-the-meter application can actually offer this or really that's sort of bundled in the other use cases. So in terms of market value of these services, I've got a ranking here. I would say that there's an asterisk here, highly dependent, highly locationally dependent. I would say highly rule-based dependent as well. So we're going to get into a little bit later in this presentation, I'm sure some of the other panelists, but SPP is in a process right now of rewriting the rules for energy storage. So all this could change depending on how those rules are implemented. But again, looking at frequency regulation, capacity, T&D deferral, spinning reserve, which is an ancillary service, and then arbitrage and voltage support. So in terms of configurations, these are some of the base configurations, especially with renewables. There's many others we can talk, and there's some nuance to this. But standalone storage, and there's sort of 3 different flavors of that. One is the wholesale generator and load, and this would be analogous to another generator on the system as a T&D asset. So again, replacing or deferring transmission and distribution. Or both, and there's a question mark there. So I think there's some question and some tricky waters there in terms of navigating, participating as both types of assets there. And then wind plus storage, solar plus storage, and then other. That would be storage paired with either gas, there'd be combined cycle or peakers, or there's some other technologies. Now, I typically am going to be referring to batteries in relation to storage because that's the main product that we are looking at in the near term, but there are a lot of other storage products that are out there. Pumped hydro, which is basically pumping water up a big hill and then releasing it and generating electricity at the time that you need it. There are quite a few of those in the United States, and there are a few in SPP, or one, I think one large project in SPP. And then compressed gas is another storage, and there's a variety of other technologies. So I think lithium-ion batteries in particular are the technology of today, but that might evolve over time, and certainly don't want to exclude other technologies from participating in storage and being part of the resource mix, depending on the location and application. So in terms of wind plus storage, some of the attributes of wind plus storage. So putting storage on wind, the arbitrage opportunity, sort of an on-wind, off-wind, buy low, sell high. There's some revenue to be generated in that regard, and also some grid benefit. Firm capacity, as I mentioned before. The ability to participate in ancillary services and frequency regulation. One of the main downsides to wind-paired storage is that for a wind facility that's taking PTCs, production tax credits, storage is not ITC eligible. So this means investment tax credit eligible. So they're in comparison to solar plus storage, where for a solar plus storage application, storage is ITC eligible. Now there's some baggage that come with that in terms of charging limitations and products that you can participate in, but that is, in terms of comparing products in the market, that's a really important distinction. And then, curtailment abatement, in Nebraska and other parts of SPP, there's a lot of negative pricing events that, lead to curtailment or times that you wouldn't want to generate. So, storage helps with that. Ramp rate control, for utility operators, cutouts in particular for wind and high wind speed situations, I understand are not desired events. So storage, storage can help out with that. And then one thing in terms of lowest price, so wind plus storage, some numbers on the last bullet there. These are some published prices from an RFP earlier this year with Piesco in Colorado. So wind paired with storage, bundled price of $21 per megawatt hour versus $36 for solar plus storage. Now, I will say this, the duration of the storage wasn't listed, the energy or the power level of the storage wasn't listed. There were a lot of caveats to this comparison, but in general, especially in Nebraska and other areas, wind is going to be your lowest cost resource. So wind plus storage typically on an energy only basis is going to be your lowest cost firm resource in terms of dollars per megawatt hour. Now that may change here over time as the PTC ramps down and the ITC continues for solar, but that's just something to consider. This is just a quick chart here in terms of comparing wind plus storage and solar plus storage and standalone storage. I won't go through the whole thing, but the main takeaways as discussed, if you're interested in managing on wind versus off wind, wind plus storage is a great option. Also in terms of keeping the absolute lowest cost of energy. Solar plus storage is the best option if you are looking for just capacity. If you're looking at terms of $1 per kilowatt month capacity price, and then standalone storage, is not to be dismissed either. There are a lot of benefits there, and in particular, if location is really important. So if you need to be on a transmission highway or or close to load where solar or wind is not an option, standalone storage. So I think that broadly that all of these different configurations are going to be implemented. In SPP and hopefully in Nebraska here, and they all have their merits depending on the application and use case. So moving on to a little bit in terms of challenges. So market participation has been a challenge for storage. Storage is a unique resource. It's a energy limited dispatchable resource, so it doesn't really fit in the buckets of dispatchable gas or intermittent solar and wind. And so FERC issued an order earlier the year, FERC 841, that instructed all of the ISOs to essentially write their rules so that storage can participate. Same with interconnection. That's FERC 845 also issued an order this year regarding interconnection for storage, and I'll talk a little bit more about that. And then regarding that compensation, and then I'd say predictable cash flow is always an issue for storage projects in terms of getting contracted, and state mandates and long-term PPAs by utilities have helped that in a variety of markets. Just real quickly on 841, as I said, it was issued earlier in the year. Compliance filings are due in December with implementation December of 2019. So, this is, it requires the ISO to insurance storage eligibility for all the products they are, quote, technically capable of providing. So I will say that the interpretation of technically capable is varied widely across the United States, but is going to be an interesting thing to watch. And then 845 regarding interconnection, the compliance filing was to be due in November, but that actually got extended. I think there's been some discussion that SPP might still file it, but we'll have to wait to see if that happens. But essentially got extended at FERC. So really pleasure to speak here today, and look forward to your questions at the end. Thank you.